Inside a modern, high-end processor under heavy load, the sheer amount of thermal energy being generated is extreme. Processors in 2026 are routinely pushing past 300 watts of power draw. If that silicon hits 90 degrees Celsius, thermal throttling instantly engages, tanking your frame rates and slowing your productivity tasks to a crawl. This leaves PC builders caught between two loud, conflicting voices: aggressive marketing campaigns pushing expensive liquid coolers, and hardware purists insisting traditional air cooling is the only safe bet. But evaluating cooling hardware doesn't happen in a vacuum. Your correct choice is entirely dictated by exactly two constraints: your specific CPU wattage and the physical geometry of your case. This chart maps out these variables: case size on the bottom, CPU heat load on the vertical. A mid-range Ryzen 5 lands down in the lower right, low heat inside a standard case. But drop in a high-end Core Ultra 9 and you jump to the upper right quadrant, a completely different thermal reality. Applying a one-size-fits-all cooling rule to these vastly different quadrants is how builders end up bottlenecking their expensive hardware or wasting money on capacity they will never use. Let's establish the baseline standard for reliability: traditional tower air coolers. They work through simple convection. Copper heat pipes pull heat away into a stack of aluminum fins, and a fan blows it away. The main advantage here is indestructible longevity. There is zero risk of a liquid leak, and the only mechanical parts that can ever fail are the fans, which cost a few dollars to replace. But try to cool a high-wattage processor with air, and you run into a physical wall. Dual-tower coolers large enough to handle extreme heat are massive, and they physically block access to your RAM slots. They also exert heavy mechanical pressure on the motherboard socket and require exceptionally large PC chassis just to close the side panel. So while air cooling offers bulletproof reliability, it is severely restricted by physical space and compatibility on modern high-end motherboards. All-in-one, or AIO, liquid coolers exist specifically to solve that spatial problem. Look at this AIO water block cross-section. A pump forces liquid through ultra-fine copper microchannels directly over the processor, capturing heat fast. The fluid carries that heat away from the crowded socket, pushing it to a slim radiator mounted elsewhere. This relocation of heat is exactly why small form factor builders rely on them. When you are building in a miniature case, clearing the physical socket area is your absolute highest priority. A smaller 120 or 240 millimeter radiator has less overall surface area than a giant air tower, but it gets the bulky metal off the motherboard, allowing you to fit high-performance cooling and tall memory modules into tiny spaces. For compact builds, accepting a slightly higher baseline temperature from a smaller AIO is the mandatory compromise required to achieve physical hardware clearance. Then there are the power users, running 24-core or 300-watt processors. Dissipating that much thermal energy requires force. You need high static pressure fans forcefully driving dense streams of air straight through tight radiator fins. For top-tier CPUs, massive 360mm AIOs are a physical necessity. Their massive thermal mass absorbs heat spikes, preventing the processor from immediately thermal throttling under heavy load. However, buying a large liquid cooler does not guarantee a silent PC. This chart compares the acoustic realities. A 360mm AIO with low RPM fans is often the quietest option. A high-quality air cooler sits comfortably in the middle, but a cheap AIO with high-pitched pump whine can easily be the most irritating sound in your room. Extreme processors demand 360mm AIOs, but using one requires a large case footprint and accepting the eventual risk of pump noise or mechanical failure down the road. To match your silicon to the correct cooling hardware, we can map these variables into a simple decision tree, starting with your CPU class. If you are a value or mid-range builder using a 65 to 105 watt processor, follow this branch. Your processor does not generate enough heat to justify an expensive 360mm AIO. Buy a quality tower air cooler and put the saved money into a better graphics card. If you are building in a small form factor or mini ITX case, you take the second path. Your main constraint is geometry. Prioritize socket clearance and cable routing by selecting a compact 120 or 240mm AIO. Finally, if you are a high-end power user generating 300 watts or more, you take the last path. Air coolers large enough to handle this heat load are incompatible with modern motherboard layouts. you need a 280 or 360mm AIO. Following this exact matrix ensures you buy the correct cooling hardware without bottlenecking your performance or wasting your budget. As of late 2026, the PC market is in a unique economic position. While memory and storage prices remain volatile, cooling component prices have stayed completely flat and stable. Pragmatic builders should take advantage of this stability by investing in actual cooling performance rather than aesthetic gimmicks. Allocating your budget towards customizable LCD screens or excessive RGB lighting is a mistake if it forces you to compromise on core thermal capabilities. Prioritize tangible specifications instead. Look for radiator thickness, high-quality static pressure fans, and reliable long-term pump warranties. A cooler's primary job is not to look good on a desk. Its job is to ensure your expensive silicon survives the extreme thermodynamic demands of the modern computing era.